Multiply that out, what degree would that be? It would be the fourth degree. And is that positive or negative? It's negative. So is it going to finish up or down? Is it going to start up or down? Why is it going to start down? Because the even will make sure that they are the same. Notice that this one passes through 4, and it passes through 0, and 0 is a triple root. Go ahead, given that information, see if you can draw the graph that's a fourth degree polynomial, starts down, finishes down, triple root at 0, and then passes through 4. See what you can come up with for that. That's what I should be seeing. Are you good?
Wait, I have a question.
Yep.
Why is one side high and the other side is like not?
So how did you draw it?
I drew it like a pen.
So you drew it like something like, say like that?
Yeah.
So the problem is that you have to show that this is a triple root. And so as it's a triple root, you know that as it passes through 0, that it's going to flatten out. So this triple root piece must be shown. Okay? Try 14, all on your own. Go. Get it?
Yeah.
Hi.
I have a question. So how do you know like when it like stays completely above the like x-axis versus when it like goes below? Cause like I had like kind of like a parabola.
Okay. So did you pass all the way through here? Okay. So again, in this situation right here, excellent question, Viv. I would like you to ask more questions. You have a great voice, and everybody's asking the same thing. Okay. So good job. So when it's squared, we know that it makes a parabola shape at the spot it touches. So see right at -5 there, if I were to zoom in, see how it makes a parabola shape right there? So if it's squared, that's a double root, it bounces off. And then you can see that here as well, at 2, it bounces off because it's squared. So if you have a square that's a double root, it's going to touch and bounce off. It will not pass straight through. Whereas Viv, in this situation, that's a single root, so it just passes through. Reckon?
Like, so the opposite of that, like, so for 13, since it's triple root, and then you add another x on there, then you'd like just kind of do it a different way.
I know that for 13, I know that I have to start here. I know I have to end there, right? We decided that. Starts down, finishes down, right? And we know that it's a triple root here, and we know that it is a single root there. So now it's just a matter of completing the rest of the puzzle.
Gotcha.
Okay? We'll practice a couple more. But Viv, just another point here, and everybody along with me, when you square something, what happens to something when you square it? It makes it, and when you square this, it makes it. So we have a positive times a positive, which would be a, that means that the graph should always be above the x-axis, and is it? Yeah, it is. So that's something that confirmed our work as well, okay? Try 16 on your own. Go, 16 on your own. Oh, we got one that's not here. Here you go.
Opposite side.
Doing great today, John.
Oh, thank you. You too.
Thanks. I didn't try today. It was a late night and I kind of lost steam. I did not hear Alondra compliment your attire today.
I did.
So Viv, Brecken, those who had that question there, sometimes I put a D if it's a double root or a T if it's a triple root, so it reminds me what to do. But remember, in this situation, I want to end going up, I want to start down. All the others are just going to be single roots. So I'm going to pass through, pass through, pass through. When I get to this one, I just touch and bounce off.
Why would it start down again?
Well, it's a fifth degree.
Oh, it's 5?
Yeah.
4.
I thought it would end down.
But then you got a squared.
Oh, shoot.
Why did you say it would end down?
Because it's odd.
Because it's odd. Okay, so we determined.
I have them backwards.
So do you have it be positive? If it's positive, it will finish up. If it's odd, it starts and ends opposite direction.
Oh yeah.
So it's
Like,
wait, I'm confused.
Everybody try 17. Try 17.
I
Okay?
had this right, but then my graph was like.
So see how you started up here?
Yeah.
You want to start down here.
Oh, okay.
So you want to start like that, and you want to
Oh,
end
the.
like that.
Okay.
That's how you want to end. That's how you want to start.
Okay.
So you had basically the same thing. You just had it upside down.
Yeah.
Okay. Okay.
Okay.
Hi, Abby.
So this one, they're all positive, but it still dips down.
Yes.
That don't make no sense.
Bracket. Right here.
I'm here.
Okay. Suppose you had x to the third. Do you agree that that's negative? I'm sorry. Do you agree that that's odd?
I do.
Okay. If you take a negative number to the third power, are you going to get a positive or a negative?
It could be either.
Nope, you're going to get a negative.
Oh, yeah, it's gonna be negative.
Okay. So just because it's odd does not, or just because it's these are all positive doesn't mean it never goes below the x-axis.
Yeah.
The fact that it's positive tells us how it ends. It ends going up.
So if it was like positive and it was even, then it couldn't go below.
It could go below. It's just meant, like, for example, suppose I had this. So bracket, suppose you had that, okay? You agree that that's even?
Yeah.
Okay, fourth degree, it's positive, so it ends up, it starts up.
Yeah.
So as I look at this, 1, 2, 3, 4. Okay?
Yeah.
It's got a double root there. So it starts up, it passes through, double root.
Uh-huh.
So yeah, it does drop below the x-axis.
Yeah.
If it was x minus 3 squared times x plus 4 squared, well, now that is always going to be positive. It will never drop below the x-axis.
Uh-huh.
That's different.
if it was like negative x, something positive, something negative, and another thing positive, we would consider. Okay.
Folks, turn in your homework. Look at a couple problems real quick, okay? As I talk with other people. Turn in your homework. Okay, we're gonna go back and forth a couple times between our homework and notes, okay? I've got Ingrid right over here. You guys are gonna start a couple of these problems. The one on the front, they are all factored for you. On the back side, you just need to factor them. So it's a practice of factoring, got it? We have other things to do today, but I want you to start there. After this, we gotta talk about division. So in this situation, so just to be clear, are you okay with that?
Yeah.
Okay, so then negative times the negative, so that would be positive. Yep, so this would be a positive x, it would be positive, and it would be a fourth power. Yes. Yep. Yes.
Starting it, I think.
How do you graph it when it starts down, but it's like a parabola? I don't know how to figure that out.
So it's 1, 2, 3,
Ready?
Yeah.
Double root.
I think so.
Triple root.
Okay, thank you.
That's it? The good thing is that you'll continue to practice graphing these for the next, week and a half. It's not something we do and just leave behind. In fact, what's great about this test is I could literally ask you one problem on the test. It'd be a large problem, but by the time we get to the end of this unit, just one problem would summarize everything that we've done in the unit. And it helps bring it together, which is why this unit goes very well for people.
Do we know how to do this?
Yep, so you would factor those. So like this one, for example. Oh, I'm sorry. So this one we would factor on x squared. And you get x squared plus 4x plus 4.
So yes.
And then that factors to x plus 2 times x plus 2, or x plus 2 squared. So then you can graph it. So all the ones on the back factor.
Hypothetically, if we got a 66%.
Yeah.
Hypothetically, how much would that bring my grade down?
I'm really good at math, but I'm not that good at math. Okay. So, alright. I mean, I'll put it in the grade book this weekend.
Perfect.
You decide if you want to retake it or not.
Yep. Well, I mean, I'm not insinuating that was my grade, but hypothetically, if that was someone's grade.
Right, well, even that was Devin's grade.
Yeah.
I'm giving you about 3 minutes to practice some of those. I'm going to try to make sure that that's up online. Looks like the answer keys are up. It says conferences on Monday this next week. That was from last year. Conferences are a week from Monday. We do not have school a week from Monday. Get a 3-day weekend.
Let's go.
Want to come in and see me and do some math?
A week from.
You fine by me? A week from Monday.
Oh, we do have school on Saturday, but the Monday after.
Wait, were you asking about that? Yeah, Mr. Goods.
Yep.
Were you gonna go over 17? Because,
Sure, yeah. So 17, if you notice, we've got a double root at -4, and we've got a triple root at 0. So this is a fifth power, and it's positive. So once again, because it's positive, it ends up. Because it's odd, it starts opposite. So I start down here, I end up here. Along the way, as I start, I have a double root, so I just bounce off. A triple root, flatten out, pass through.
we can't factor.
Another minute and a half?
Can't factor this.
Yep. So it's you just
Why don't
factor
you
out
go
negatives,
above
it's
it?
just a minus, right?
Oh.
Oh, yeah.
It's just gonna touch the point.
Yeah, so if this was, so Callie, if it was like this, well, now that tells me to pass through because it's a single root. But when I see squared, I can't, I gotta bounce off.
Okay.
Anytime you see the square, just gotta bounce off of it. Another minute before we move.
The square.
Oh, yeah.
Touch the mirror with the arm, and then you have to go back down.
No, once you, so, wait, did you plus?
It's negative because it's 3 minus x. You have to switch
Ten seconds, 5, 4, 3, 2, 1. Here we are. So, there was a while in which people taught things differently in our district, and I need help with you to understand where you're at. The truth is that not everything factors very well when we're dealing with polynomials. And that is truly actually the essence of our work during this unit, is try to figure out things, how things factor, even when we don't see it. And it's pretty cool when it results. But if I want to take 2,143, we have to talk about division in order to get to our next step. I'm just wondering, okay, I'm going to do this division, and I need you to then share with the person next to you whether or not this is consistent with how you learn law and division. I say, how many times does 8 go into 2? It doesn't. How many times does 8 go into 21? It goes in twice. That gives me 16, and I subtract. That gives me 5. Drop the 4. 8 goes into 54 6 times. That gives me 48. I subtract, I get 6, I drop the 3. 8 goes into 63 7 times. That gives me 56. I subtract, and I get 7. So that has a remainder of 7. Talk to the person next to you. Is that consistent with how you learn law and division? Yes or no? Go ahead, talk.
That's so different. Like, what is this?
Is that not how you learned it?
No, it's like this.
Okay. Here's how some people are learning division, okay? They don't know how many times 8 goes into 2,143. So they make a guess. They say, well, I'm guessing it goes in 20 times. Well, 20 times 80 or 8 is 160. So then they subtract it. And they get 3, they borrow, they get 8, they borrow, they get 9 and 1. Oh, well, maybe it goes in more than that. I'll try 100 times. That will give me 800. I subtract, I get 3, 8, 1, and 1. Oh, I bet it goes in 100 times again. And they get, they subtract 800 again. They get 3, 8, and 3. Oh, now 8 goes in 383. I'll try 30. Well, that's 240. I subtract, I get 3, I get 4, I get 1. You guys get the point what I'm doing? And what they do is in the end is they add these up, and those will add up to 267. They call it the candy cane method. There was a period in Albert Lee where all the kids learned the candy cane method. Is anybody familiar with the candy cane method?
No.
Good. All right. It's very difficult for me to work with people when they talk about how law and division does not have a place in our world at all because you could just use your calculator all the time. And they say, when would you ever need to use law and division? And I say, when they're dividing polynomials. They're like, what? I've never done that before. I said, I can tell. That's why you don't think division matters. So just think of how hard it would be if we didn't learn how to divide correctly, which is the way it is in some people's world. I apologize if that was your world in any way, shape, or form. So let's not think of the candy cane method. Let us do the long division method. Our good friend Nina, she has a little bit different background, I'm guessing. Nina, please stick with us as best you can. Okay? X plus 2 goes into 3x plus 6. I'm not going to spend a lot of time on this, but I want you to get exposed to the long division piece because we still have one piece I want you to quick see after this. This is a binomial. I have to see it fit into another binomial. What do you multiply x by to get 3x? 3. 3 is a constant, so it goes above the other constant. I then multiply the 3 back through. 3 times x is, and 3 times 2 is, I subtract and I get 0. So that means it goes in 3 times with no remainder. We good?
Yeah.
That should not be surprising, because if you had 3x plus 6 divided by x plus 2, notice you could have just factored a 3 out of the top and then divided it off, and it would all be good, right?
Yeah.
But sometimes things don't work out that simply, and it's difficult to see. So let's look at our next example. We have x cubed minus 6x plus 4 divided by x minus 2. I'm going to put the x minus 2 here. And underneath I have x cubed. Anybody know what goes next? 0x squared. Okay, you have to account for the 0x squared. It's a placeholder. And we start by asking this question. What do you multiply x by to get x cubed? X squared goes above the x squared terms. I then multiply it through. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. What do I do with those two things? I subtract them. Very careful with your subtraction. This is where you make mistakes. Look, x cubed minus x cubed, that should happen every time. We defined that when we said, what do you multiply x by to get x cubed? We made it so that first part would go away. That's what we did. Now the next part is 0x squared minus negative 2x squared. What is that going to result to? Positive 2x squared minus 6x. So when you make mistakes, it's usually because of your subtraction. I bring a binomial because I have a binomial, and now I start again. What do you multiply x by to get 2x squared? 2x. I go ahead and I take that 2x and I multiply it through. 2x times x is 2x squared, that's what we thought it would be, and 2x times negative 2 is negative 2x. Now I have to subtract. What? Sorry, negative 4x. The 2x squared minus 2x squared is, and then I have negative 6x minus negative 4x. What's that going to give me? A negative 2x. Plus 4. We start again. What do you multiply x by to get negative 2x? So I multiply, I get a negative 2x, I get a plus 4, when we subtract those, we get 0. It divides evenly. We're good with that? Okay, I don't want to waste our time, so please go to your homework. And what I would like you to do is problem 2D in your homework. 2D in your homework, okay? You okay with that? Get 8?
Yeah.
Okay. I'm going to show you some things that are really cool. I told you in this unit is very important. Like everything I say really, really matters. Okay? So this is something really, really matters here. First of all, the remainder is 8. Here's how we write the remainder. Suppose that I had the following. Suppose I had 7 divided by 3. Would everybody agree that 3 goes into 7 2 times?
Yeah.
With a remainder of 1? So it's 2 1/3. See how you put the remainder on the top and the divisor on the bottom? So when you write x squared plus 2x minus 10, if the remainder is 8, you write plus 8 divided by x plus 1. You see that? That's not the cool part. This is the cool part, okay? Viv is taking the test, and she's like, shoot, I'm really wondering, like, is this right? Like, I came up with a remainder of 8, okay? And here's how she can see if it's right. This is going to help you guys a lot, okay? What number would you plug into x plus 1 to make 0? -1, right? Substitute that in here. What is -1 cubed? -1. What's -1 squared times 3? What's -8 times -1? -1 plus 3 is 2, plus 8 is 10, minus 2 is 8.
There we go.
It's called the remainder theorem. You can always check to see what the remainder is by simply taking the solution to the divisor and plugging it into the polynomial. It'll tell you right away. That's kind of cool, isn't it? Yeah.
So,
Go ahead.
I
I don't know about you guys, but I'm not really into the whole long division thing. Are you? I would like a quicker and a faster way. Now, on your assignment, I want you guys to know that for your dividing polynomials that you have there, all I want you to do is that front side. You don't need to do the back side, okay? I just want you to practice the long division piece. But I need time today to get to the lesson on Monday, so I want to push into the next piece. This is very important. We've got about 12 minutes, and we should be able to get it. Sometimes what I like to do is I like to use what we call synthetic division. Synthetic division is faster and it's quicker. You have to know how to do both. We use both. And all I do is I look at this, and what do you plug in to make 0 for x minus 1? So you put the 1 there, and I draw a half box around it. You got a different method, say you're from Brazil or something, do it differently, then you go ahead and do that, okay? I put the coefficients across the top. 1, -4, 2, and 1. And then I put a half box at the end, and I write R for remainder. The nice thing about synthetic division is it doesn't involve dividing and subtracting. It involves multiplying and adding, so you're less likely to make mistakes. Furthermore, it's really fast. You start by dropping the 1 down, and then you multiply. 1 times 1 is 1. Then you add, -3. Then you multiply. Then you add. Then you multiply. Then you add. The result tells you your solution. This is always your constant. This is your x. This is your x squared. So result is 1x squared plus x minus 1. Or I'm sorry. 1x squared plus 3x, or minus 3x. That's your resulting polynomial. Simple as that. Let's try another one. Let's look at B. What number do you plug in to make 0? A negative 2. So what do I write across the top?
4, 8, 0, 0.
That would take us a while to divide that out using long division, wouldn't it? So let's use a synthetic. What do I start by doing? Dropping down the 4, and then multiplying, you get negative 8. Then I add to get 0. Multiply, get 0. 0, 0, 4, negative 8, negative 15. I know my result. This is my constant. This is my x. This is my x squared. This is my x cubed. So I get 4x cubed. I get a plus 4. And then I get a minus 15 over x plus 2. Piece of cake upside down. Skip C. Try D on your own. Try D on your own. Go.
Good morning. Please join us in celebrating our cross-country student as he heads to his state competition. You can line the hallways if you are able until the drum line and cross-country student and coaches have passed, and then you may return to your classrooms. Thank you.
Let's go.
I would actually cry.
They said, that you
I'll shoot you one.
Wait, guys. So if there's some questions you're gonna ask us to do it the regular way?
I will ask you a couple questions on the test to divide using long division.
Okay.
Because there are times that synthetic division does not work.
Yeah.
Most of the stuff we do, synthetic division works, but every once in a while it doesn't.
They're actually like they're in. So then we can only match them. If not next week, they can.
Okay, let's see what you got. -5, you should have across top -1, 1, 0, and 6. So you drop the -1, you get a 5, 6, -30, -30, positive 150, 156. Is that what you get?
Yeah.
So you got x squared minus or plus 6x minus 30 plus 156 over x plus 5.
Yeah.
Good. So
I was
the question is, what's the whole point? What's the whole point? And this is the point. This is where you want to understand, because this is where we get on Monday. If you had 12x squared minus 17x and then minus 40, and you're trying to solve that polynomial equal to 0, okay? Does everybody agree that that's a difficult one to factor? Yeah, and I've already done the legwork for you, okay? I've factored it already, and I've said that it actually factors to, I created the problem over there, it factors to 3x minus 8, and it factors to 4x plus 5. Everybody convince themselves by looking at that that's the correct factoring? Then what I want you to notice is this. When we find the solutions, you set up 3x minus 8 is equal to 0 and 4x plus 5 is equal to 0, right? That's what we set up. So as you set that up, when I solve, I get x is equal to 8/3. And when I solve this one, I get x is equal to -5/4. Everybody with me? Here's the really, really cool thing. If you look at it, we actually could have made a prediction ahead of time as to how this would go. Notice the 3 and the 4 on the bottom, they are factors of 12. Notice the 8 and the 5, they are factors of 40. So it turns out that when you don't know a solution to a polynomial, you can look at factors of the back and factors of the front and divide them, and it's a really, really good guess. We end with this example 1 right here, which is where we pick up on Monday. Does everybody agree that x cubed minus 7x minus 6, that doesn't factor in a way that we know how?
Yeah.
So what I could do is I could come up with, I call my p's and my q's. P's are factors of the last number, and q's are factors of the front number. That's all we're concerned about. We can see that it is a third-degree polynomial, but we list our p's, which are factors of 6. And what are the factors of 6? 1, 2, 3, and 6. And then q's are factors of 1, which is just 1. So the actual choices for solutions are any of the p's divided by the q's. So 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. And 6 divided by 1 is 6. Good. There's where I'm at. So out of all the numbers that are in existence, which is infinite, right? We have narrowed the entire infinite number list down to just 8. That's pretty good, isn't it? And so which one of these might work? Well, we just take a guess. And I know that seems troubling to you, but remember, we just checked. You can see if something is a solution by plugging it in. If the remainder is 0, then it divides evenly, right? So, which number would you like to check, Alondra? I thought you just checked. I'm sorry, I saw you smile, so I thought you already tried something. Anybody got a number they want to try to check? 2. We'll try 2. 2 cubed is 8. And 8 minus 14 is -6. Minus 6 is -12. So 2 did not work. Give me another number. 1. I try 1. 1 minus 7 again is -6. Minus 6 is -12. 1 did not work. 3. 3 cubed is 27. Minus 21 minus 6. Did that give you 0? Yeah. It turns out that works, and that's going to help us as we move forward on Monday. So, you can be working on your first 2 assignments. Your first 2 assignments, we'll pick up with this on Monday.